Alrighty folks, so in this video we're going to just do it quick and dirty. Here's how to graph a rational function and finding the discontinuities and the asymptotes. Alrighty, so notice I have my function here. F of x is x plus 3 divided by x minus 5, x plus 3. Alrighty, well, here's what you do. Step 1. Step 1. Find your discontinuities. Discontinuities. I apologize, I was distracted because my dad came in. But we want to find our discontinuities, so we'll start off 1a, I suppose. Step 1a is find the vertical asymptotes. Again, vertical asymptotes come about. Vertical asymptotes come about when you have a number, some constant, over 0. Okay, so what's going to happen here? Well, there's two options because our denominator has two factors which could both potentially be 0. So the answer is either x equals 5 or x equals negative 3, because those will make each of those factors 0. When I plug in x equals 5, we're going to see that on top you're going to get 8, and on the bottom you're going to get 0. And so this is where we're going to find our vertical asymptote. Well, what's the deal with this other one then? Well, when I plug in this one, we're going to get 0 over 0, right? Negative 3 plus 3 on top, negative 3 plus 3 on the bottom. This is not a vertical asymptote. This is what tells us is a removable, I keep spelling this wrong, I apologize. Removable discontinuity, or you could just abbreviate it RD if you want. Discontinuity at, and again, this is going to happen at x equals negative 3. Now, I would also like us to know where that point is vertically. So how do we figure that part out? Well, this goes back to the point of graphing step 2. Graph the simplified equation, I'll say. Simplified function by canceling out the simplified function. So our original equation is x minus 3, no, plus 3 over x minus 5, x plus 3. If I cancel out the x plus 3's, we're going to get just 1 over x minus 5. And so this graph is just going to look like this. Our vertical asymptote now, again, is going to happen at x equals 5, which is right here. We're going to have also a horizontal asymptote at, again, the x-axis here. For now, oops, sorry about that. That was an accident. For now, the horizontal asymptote is always going to be there. In the later examples, in a couple weeks here, that will not always be the case. But for now, we can also see, we're going to have 1 divided by potentially really big number. It's going to be a really small number. And so that's why we have that, the asymptote there. So our graph is going to look like this. Like so, and like so, right there. Now we have, again, our removable discontinuity happens at, actually, let's do a different color here. Let's use green. At negative 3. So that's going to be right here. So the question is, what is the y value there? So we know that point is at negative 3 comma something. How do I figure out where that is? Well, you're going to take that point and plug it into the simplified equation, because that point does exist on the simplified graph. Oop, right there. So let's plug that in to find the y coordinate of our removable discontinuity. Plug into the simplified equation. And so if I do that, I'm going to have 1 over negative 3 minus 5, which is negative 1 over 8. So we know that this point is actually negative 3, negative 1 over 8. The last thing here, while we're at it, why not find the domain and range then? So for this function, and again, we'll kind of tie it all up in a neat little bow. this graph is f of x equal to x plus 3, x minus 5, x plus 3. The domain, well, again, we know it's all the real numbers other than 5 and negative 3. And our range, well, we know that the y value cannot be 0. So f of x cannot be 0. And also notice that it cannot be equal to 1 over 8 because that part has been, again, plucked out of the graph. Cannot be equal to negative 1 over 8. So hopefully this video helped, and hopefully you feel pretty good about graphing rational functions. Notice for these first couple ones that we're going to see, the equations are very relatively simple. We are going to see spicier ones, in which case you're going to have to factor something even more complicated than a quadratic. But we'll get there later. So that's why the next couple videos that you're going to see for a while are going to be all about factoring. Okay? I'll see you in the next video, folks. Thanks for watching.